So far we've talked about resistors and fixed voltage and current sources, which we depicted as a current as a circle with an arrow or a plus or minus in it, or a battery stack. Now I want to talk about dependent sources. They look similar to independent sources, except we draw them with a diamond shape rather than a circle. And the basic idea is that the current in a current source, or the voltage in a voltage source, depends on the current or voltage somewhere else in the circuit. And so we basically have four options. We can have a source controlled by current, and it can either be a current-controlled current source, or a voltage-controlled current source, or a current-controlled voltage source, or a voltage-controlled voltage source. So, for instance, I could say that there's a current-controlled current source model of a transistor we haven't talked about yet, but it has three leads, a base, a collector, and an emitter. And the basic one of the ways to model the way it works is that if there's a current flowing in on the base, it controls a much larger current on the collector, so that if I put a little bit of current here, I multiply that by some number beta, and that's the current on the collector. So basically my current-controlled current source is here. It's a current source because it has an arrow in it, and its value is beta times IB. There will always be a current or voltage from another part of the circuit here, and so that tells me what this current is, and that's now fixed, independent of whatever voltage is across that circuit. But it does depend on what the current is here. If this current changes, that current will change as well. An example of a voltage-controlled current source is a FET transistor, field effect transistor. In this case, the voltage across a very large resistance controls the current on this side. In this case, we use G rather than beta. It doesn't really matter, but notice it's the VGS, which is the gate source voltage of the FET. Finally, a voltage-controlled voltage source is how we model an op-amp, which we'll talk about soon. In this case, it's not a full circuit. In other words, it's a disconnected circuit, sorry, in which case you apply an input voltage on one side with a very large resistor, and that voltage controls how much current, the voltage on an output here. And so if there's a large voltage here, then we have some much larger voltage here. A is usually very, very large. So there's a couple things to remember about dependent sources when we're solving circuits with them. The first thing is they are linear. That means that we can use all the tricks we talked about in the last section, Thevenin's theorem, superposition, and things like that. However, we have to be careful with superposition, because in superposition we normally turn off all but one source, but the dependent sources we cannot turn off because they depend on a current somewhere in the circuit. So when we're solving a system with superposition, we don't turn off the voltage, the dependent sources at all. We just leave them in and calculate.